Water is the invisible thread that connects ecosystems, people, energy, and agriculture. But today, that thread is breaking. Earth is a blue planet, covered by water for more than 71%, with over 1 billion cubic kilometers of water. However, only a tiny fraction of that percentage, just 0.01%, is accessible as fresh, surface water. And unfortunately, this small share is increasingly under pressure. In this lesson, we will understand the reasons behind water stress and how we can act to mitigate its impact on society, the economy, and the environment. Let's start with some numbers. Globally, water consumption is growing at twice the rate of the population. Scarcity is not just a physical issue, it's also an economic, social, and often political challenge. The water stress coefficient, that is, the ratio between withdrawal and availability, now exceeds 35% on a global scale. Projections show it increasing significantly by 2040. Values above 25% indicate a condition of water stress. By 2050, 31% of the world's GDP will be generated in regions at high risk of water scarcity. So the problem isn't just how much water we have, but also when, where, and how we use it. What are the pressure factors affecting water resources? Agriculture uses about 70% of the fresh water withdrawn globally, taking it away from other uses and creating conflicts between sectors, between agriculture and energy, between civil and industrial uses, and with ecosystems. During periods of drought, these conflicts become even more apparent. For example, in the Colorado River Basin in North America, the construction of dams for hydroelectric power generation and to supply water for agriculture has significantly reduced the flow to the delta, allowing saltwater intrusion that harms both the ecosystem and agriculture itself. Moreover, the growing urban and industrial demand in metropolitan areas, such as in Cape Town or Chennai, India, intensifies competition for resources, fueling inequalities in access and distribution. However, these conflicts are not limited to sectors, they also involve states. Over 60% of freshwater resources flow through basins shared by multiple countries. Think of the Nile, Tigris, Euphrates, Indus, and Colorado. And the natural power imbalance between upstream and downstream in these basins often leads to tensions and conflicts. Transboundary cooperation is fragile, but essential for water security and peace. Last but not least, climate change. Global warming alters the availability of water resources, increases uncertainty, and intensifies extreme events, causing more frequent and prolonged droughts, heavier and more concentrated rainfall, stronger cyclonic activity, reduced snowfall, and earlier snowmelt. This makes water management increasingly complex. What can we do? Dams, aqueducts, and desalination plants, the so-called hard path, have played a key role in the history of our socio-economic development and can certainly still represent an important way to adapt to climate change. However, they are often expensive, not very adaptable or flexible, and have significant impacts on ecosystems. We need a transition toward systems that are flexible, efficient, and resilient. A soft path that certainly does not rule out investments in new infrastructure, but includes efficiency, governance, knowledge, and leads to better use of existing infrastructure. Among these, for example, are demand management through water savings, reuse, more efficient irrigation, or economic tools like insurance, water markets, or smart pricing. And then participation and transparency through the involvement of stakeholders and co-design. Today, digital technologies offer powerful tools not only to monitor, but also to understand and optimize water systems in an integrated way. We are immersed in a real torrent of information. Satellite data, traditional sensor networks, citizen science initiatives, and reanalysis data provide an unprecedented picture of climate dynamics, water resources, and their interactions. In this context, IoT sensors make it possible to monitor consumption, losses, and water quality in real time. The digital twin dynamically simulates infrastructure, demand, and climate scenarios. AI and machine learning support more efficient decisions on allocation, maintenance, and emergency response. The integration of large amounts of data makes it possible to develop targeted information services that can support both operational and strategic decisions. Digitalization, therefore, is not just a matter of technology, but of the ability to integrate data, governance, and adaptation to make water systems smarter, more resilient, and more sustainable. The water crisis is not a fate, it is a challenge we can face with tools, knowledge, and collaboration. Investing in sustainable, inclusive, and smart solutions means turning water from a problem into a lever for resilience. Effective water management is one of the pillars of climate adaptation and equitable development. Innovation, adaptation, and water justice will be the key words for building resilient, fair, and sustainable systems.